Hi, this is Christoph Limpelaer, and this is episode number 8 of the Redis and Laravel series. In this episode, we're going to talk about 4 different data types in Redis. Now, one of the series viewers actually came to me and asked me if I could dive a little bit deeper into what all these different data types are and how to use them, and give a few examples with use cases. So that's exactly what I'm going to do in this episode. Walk you through those 4 different data types and see how they can be beneficial to your application. And let me tell you, Redis and its data types can do quite a bit. So let's go ahead and get started and dive in. The first data type we're going to take a look at today is lists. Lists contain strings sorted by insertion order. They're actually implemented with linked lists, which means that we can add items to the head or tail of a list, as well as before or after a value currently in the list. Even if we have 10 million items in a list, adding an element to the head will run in the same amount of time as if the list had one element. And we can return a range in the list, or we can also do things like trimming a set or popping the first element in our list. So as a use case, for example, this can be very useful for queues. If we are queuing jobs, the first element in our list can be popped to process it. However, if we have a more urgent job that needs to take priority for whatever reason, we can push it at the head of our list. Or we could also do that for a job that failed the first time and we want to try it again. Now please note that lists also support blocking operations. If you plan on using Redis for queues, definitely check those out, because this is very useful when queues have multiple lists. For example, you have one process that stores the job or jobs, and another process to actually do the work on the job. The one that does the work will continually pull or look for a job even if the first list is empty. This causes a lot of useless commands and adds delay to processing items because of built-in delays in Redis. We can overcome this with commands like brpop, as well as many others. This can get pretty complicated, so I'm not going to cover it here, but be aware that it does exist, and if you want to learn more about it, check out the documentation. I'll be sure to link that below the video. Now we can also use lists for social networking sites like Facebook or Twitter, where we want to list the latest posts by users. If you want to learn more about this, check out my episode number 6, where we cover more about this, mimicking a Twitter newsfeed. Now, one of the cons with lists is that they're not very fast when we want to find a member somewhere other than the head or tail. Now, I say not very fast, that's all relative, but compared to other data types, if you plan on mainly doing that with whatever you want to do using lists, like if you want to continually look at members that are in the middle of the list or towards the end of it, I recommend using a different data type. Before moving on to an alternative to this, let's take a look at a few different commands that we can run with lists. For example, if you'd like to create a list, you can use push, like so. And we're going to go ahead and add a few posts, just as an example. Alright, so we've got 3 posts in a list called MyList. Now we can pop the head element by doing lpop mylist, and it will return post 3 because it was the last thing added with lpush. Remember, when we use lpush, it will add whatever value we're adding last to the head of the list, and that's the first thing that's going to get popped. Now if we want to add an element to the end of the list instead of the head of the list, we can use rpush, like so. Now if I do lpop, I'll get post 2 instead of post 4. Okay, let's go ahead and move on to another data type. This one is called sets. And sets are unordered collections that support powerful operations, for example like intersections or unions, and you can also pull random members from a set. So this is really useful to answer questions like, what are all our article tags? Or what are all our interview tags? For example, for scalarcode.com, that could be pretty useful. And then we can also look to see if we have any tags that intersect between articles and interviews. So maybe I want to do an internal audit and see how many interviews and articles share the same tags. I could use something like intersect. Now, one beautiful aspect of sets is their speed. You can add, remove, and check for keys in constant time with big O of 1. This means that no matter how many elements you have inside of a set, it will take the same amount of time to perform one of the actions I just mentioned. Another neat thing with sets is that they don't allow duplicate keys. So if you try to add the same key multiple times, it will just be ignored. This reduces the need for things like if-else operations and declutters your code. So as a use case, you could use this for unique IP address views. If you remember from episode number, I think it was episode number 4 or 3 or something like that, we checked to see top views on pages. Unfortunately, every time somebody refreshed the page, even if they had already visited the page before, that still counted as a view count. This is not very accurate if you want to count number of unique views. In fact, it's not at all accurate for that. So you could use something like sadd, where you add in an IP address, and if that IP address is already in the set, sadd is just going to ignore the command. It's not even going to do anything at all. Now, in addition, we can do things like unions, intersections, and check for differences between sets in a very short time, as I mentioned earlier. Let's go ahead and start with intersections. Intersections have a time complexity of O(n) times m, where n is the number of members in the smallest set, and m is the number of total sets used in the operation. So this is pretty good timing as long as you don't have a whole lot of sets, or your smallest set doesn't have a lot of members in it. So for example, if we wanted to do an intersection, we could do something like this. Let's add a key 1 with values A, B, C, and D. And then we'll do, actually I misspelled that, so I'll just go ahead and do key 2 then, and C, and then sadd key 3, A, C, E. Okay, now I can do senter, and I can also add store. So senter by itself would work, but it would not store the result permanently. So instead I'm going to do senter store, and I'm going to name it K. I was going to name it key, but I messed up earlier. So K, and then key 2, key 3. And this is going to return C. And we can check that by doing smember K. Actually, it's smembers. And as you see, it returns C because that's the one that consistently showed up between key 2, and key 3. If we didn't have anything that matched, we would return an empty set. All right, so that could be pretty useful in a situation where you have a list of pictures or products or articles, and your user clicks on one of the products, and let's say, for example, that product has tags affordable and laptop. So then you know that the user is on your website to shop for affordable laptops. So there's no need to display a fancy gaming laptop. Instead, you can have a recommended laptop section, and you can pull those products by doing an senter like I just did. And you could have a recommended section or something like that at the bottom of the post. And that way you'll get more page views, but more importantly, you'll probably drive more sales that way. Now let's move on to unions. Unions have a time complexity of O of n, which is better than the first one. And n is going to be the total number of elements in all use sets. And unions are going to allow us to take a whole bunch of sets and unify them into one result. Let's go ahead and clear this out and take a look at that. If we do let's do U key 1, A, B, C, D, and then finally key 3, we're going to do just so I know which is which. Now we can do union store, just like inner store, and we'll do UK and that will return, if we do smembers UK, that will return every single one of them, A, B, C, D, and E. I can't really think of a concrete example for this as a use case. Perhaps maybe we want to take, we have a user, for example, and he or she has different comments, and we want to aggregate all those comments in one area, and maybe we store those in different keys depending on the post ID. Say there's a post 1 and post 2, and they have multiple comments in both of those posts, and we want to have a page where that user can see all their comments. We can use something like SUnion store to combine all those and display them. I just kind of came up with that. I'm pretty sure that would work really well, but I haven't tested it, so I'm not sure. If you want to give it a shot, by all means do that and let me know what the result of it is. That'd be really cool. But let's move on and talk about differences. Now, differences, just like intersections and unions, are going to have very similar commands. So I'm not going to do that again, but it would be, instead of SUnion store, it would be SDiff. And that will give you the result, the difference between all the different keys, which could also be useful in certain situations. Now, another one I want to talk about, and then we'll move on to sorted sets. One of the functions for sets that's very helpful, at least for me, is random member, ZRevRange. And then you can put in a key and give it a count, and it will return the count number of random keys from your set. If you don't put a count, it will just give you one random key, one random member from that key. Now, ZRevRange key by itself has a time complexity of O of 1, so it's constant, which is very nice. But as soon as you add in the count, it's going to turn it into n, where n is the number of count that you want to return, which makes sense. So without the count, as I said earlier, it returns one random member. There's another function for sets that's called spop. Spop is just like ZRevRange without count, where it gives you one random member out of the whole set, except spop removes the member, whereas ZRevRange does not. And with ZRevRange, and let's try and see if I can do, let's do this. Okay, so I get 3 random members. If I do that again, I will get 3 different ones. Yep, I did. And as you noticed, I used a positive number in this example, but I could have also used a negative number. And the difference between positive and negative numbers is that positive numbers will absolutely return a unique number unique member every single time, whereas a negative number does not guarantee uniqueness. As you can see in my example, it returns A, D, and D, because with negative, it doesn't matter if they're unique or not. That's the main difference between the two. A use case for this, well, honestly, there are quite a few use cases, but if you're using a relational database system, maybe something with SQL, and you have a function where you want to return all articles or blog posts or maybe a list of pictures for a user or even a list of users, and you want to use something like order by random, don't do that. That's really bad for performance. Instead, you can just store these things in a set and do ZRevRange. It's super fast. It's either constant or O of n. I mean, you almost can't beat that. So that's definitely something to keep in mind, especially if you have any order by rand in your code. I would definitely go ahead and try to replace that if you can. If you want to learn more, you can go to http. I can't type tonight. redis.io/commands sadd. And the reason I can't type is because the mic is coming. It's too close. I gotta get a stand for it. But here, I'll put this down in the comment section as well, so you can click on it. Even though this is pointing directly to the command sadd, on the right hand side you'll see all the different commands that sets offer. So that's really nice. Okay, let's move on to sorted sets. As the name implies, sorted sets maintain the order of our elements. This is really similar to sets, except that those don't have order. And we keep track of orders in sorted sets with scores. Members are unique, but scores can be repeated. And this is definitely one of the main selling points for this data type. But on top of that, we can also do things like return an ordered list, check for existing members very quickly, and access elements very quickly, even if in the middle of a sorted set. If you remember in just a few minutes ago, when we were talking about lists, you don't want to use lists if you're fetching a lot of information in the middle of the list. That's not very fast compared to sorted sets. And to be honest with you, good luck trying to do that with a relational database system as well. It's definitely not going to be as efficient. So as a use case, for example, we could keep track of scores and leaderboards in an online game. Or you could also keep tracks of votes, for example, like they do on Stack Exchange websites, Stack Overflow, Server Fault, all those things. They have voting systems where if you like the answer, you can vote it up. That tallies up scores for certain users. The highest voted answer rises to the top, etc., etc. They could definitely implement something like this using Redis. I'm not sure if that's what they do or not. I'd have to check, but it could definitely work. And you could easily return things like top posts as well. See my episode number 3. Oh, yes, that's what it was. Episode number 3, we briefly mentioned that with view counts. This is the same thing. Check out my episode number 3 on YouTube. I talk more about this in more detail. And I show you how to implement it in Laravel as well. Another thing you could do is also keep a user list in order of registration dates or something like number of posts. We could return the top 5 users with the most posts using something like ZRevRange. So ZRevRange, it's like this. That means take the list, go to the reverse, or return the reverse range of it. Say I have something like 0 to 10. That would return the, I think 9 indexes. Yeah, 9 indexes from the highest score to the lowest score, because sorted sets are sorted from lowest to highest. So this would give you the highest 10 users, if that's the case. We could also do something like return all users between ages of 25 and 30 or whatever you want by doing something like ZRange by score. Just like this, which takes a key, a minimum value, and a maximum value. You could also add in with scores, so it would show you the scores of them, and then you could limit a count. Just like in a relational database system, SQL database, you could do a limit count. This is the same thing. You could have a cap on the amount of results that you get back. And just like we looked at with sets, sorted sets can also do unions. And if we do it, we would use zunion store. Just like that. To conclude this episode, let's wrap up with hashes. Hashes are a great way to represent objects. So if you have users or blog posts and you want to store them somehow, hashes would be a good way of doing it. Also, if you have massive amounts of data, you may want to use hashes with small values because they are encoded in a very special way that makes them very memory efficient. In fact, Instagram has a post about this and how they used hashes to save a lot of memory storage. I'll try to link it if I can find the post again. It was a pretty good read. So as an example, let's say that we have users we want to store in hashes. I'll do HMSet. The M is for multiple, so I could do HSet instead, but with HMSet, I can set multiple values at the same time. So the key is going to be user1. I'm assuming 1 is the ID of the user. That should be unique. And we'll set the username and the year registration 2015, and then I'll put password test. Of course, if you actually store a password in Redis, you'd want to have it hashed, and you want to read up on security things for that. You wouldn't want to put the plain text as I did. But this is just for illustration. Now we can do hget user1 username. We could also do year, etc. If we want to get all values at the same time, we can do hget all user1. That will return everything we have. Or if we don't want to retrieve all of them, but we want to get a few of them at the same time, we can also do hmget user1 username and password, and that will return both of those. And we could also add year, and etc., and keep going like that. So as I said earlier, this is really useful, as you can see, for users, user accounts, blog posts, anything that represents objects, but not just necessarily objects. I mean, the actual number of fields you can put inside of a hash has almost no limits. I mean, apart from the available memory that you have. So you can use hashes in many different ways inside of your app, and they are very powerful. I hope you enjoyed this episode. Go out there, build something awesome, and please let me know if you do. I'm really interested in seeing what you come up with. Thanks for watching. Have a wonderful evening.